Yes. Okay, yeah, thank you for the introduction, Zhongyi. So now let's get started. So in my talk, I will basically give you an introduction at the intersection between machine learning and security. Okay, so first of all, I will briefly introduce why these two areas intersect with each other. Okay, so on one hand, as we know, machine learning provides increasingly powerful data analytics tools. And machine learning is winning over world champions in sophisticated games such as Go and StarCraft. Okay. Also, machine learning enables everyday products such as smart home assistant, fingerprint authentication, and robot assistant, okay, and so on and so forth. On the other hand, security and privacy attacks increasingly involve data. Okay. For example, right, this was in 2018. Okay, Facebook was fined for data breaches in Cambridge Analytica scandal. So Cambridge Analytica was a startup which actually may have leveraged machine learning to automatically infer the private information of a large amount of Facebook users. Okay, I will discuss a little bit more detail about how this attack works. Also, the internet is plagued by all kinds of fake information, such as fake accounts, fake reviews, and also fake news. Okay. And also, we have witnessed one of the largest scale denial of service attacks caused by compromised IoT devices, okay, several years ago. So all these evidences show us the security and privacy attacks increasingly involve data. So these two research areas, machine learning and security and privacy, naturally intersect with each other because both of them involve data. And what do we really mean by these two areas intersect with each other? Okay. Actually, there are a lot of interesting questions at this intersection. We particularly are interested in two questions. First, how will machine learning impact security and privacy as machine learning becomes more and more powerful? Second, how will security and privacy impact the deployment of machine learning as security and privacy attacks become more and more sophisticated? Okay. So I will basically briefly introduce you some opportunities and challenges regarding these two questions. So let's first look at the first question. How will machine learning impact security and privacy? First, as machine learning becomes more and more powerful, machine learning can enhance our security capabilities, okay? Which means we can leverage machine learning to better solve our conventional cybersecurity problems. For example, one basic cybersecurity problem is spam and fraud detection, okay? Like email spam, fake user on social networks, and also financial fraud. Okay, all these problems may be better solved by leveraging advanced machine learning techniques. And also malware detection, right? Another basic security problem. Although we have studied malware for many years, but still we have a lot of malware, okay, on the internet. And also software vulnerability discovery. Okay, many software are very complicated. How can we automatically find the vulnerability or bugs in a software? Okay, so machine learning or AI may be able to help these security problems. Okay, so let me give you one example about how machine learning can help us better solve security problems. Okay, this example is machine learning based fake user detection. Okay, in particular, I will give you, I will use the WeChat as an example. Okay, so as we know, I guess some students, some people in Taiwan also use WeChat. Okay, so we may know this app. So when we register an account on WeChat, WeChat will collect a lot of information about those registration accounts. Okay, for example, WeChat will collect the IP address. We will also WeChat will also require the phone number. Okay, this is especially true in China. Okay? And also we have timestamp when this account was registered, and also nickname, WeChat version, and your operating system version, like Android or iOS, and a lot of other information. Okay, so we could use machine learning. So basically, machine learning is about data analytics, right? We can we can look at the registration information of normal users, okay, and also the registration information of fake users, analyze their registration information, identify the features that the normal users and fake users are different. Okay, then we can use those features to build a machine learning classifier. Then then we can train the classifier and then use the classifier to detect fake users based on the registration information. Okay, so we actually did this, and WeChat has deployed our technique. Okay, and WeChat found that this type of machine learning based technique can detect 400,000 fake users per million registrations every day on WeChat. Okay, so this is just one example of how machine learning could help us better solve conventional cybersecurity problems. Okay. However, on the other hand, as machine learning becomes more and more powerful, machine learning could also be misused by attackers to perform better security and privacy attacks. Okay, so the defender is using machine learning, the attackers are also using machine learning. Okay, for example, attackers can use machine learning to perform automated large-scale inference attacks. Okay, and the Cambridge Analytica attack for Facebook users is one example of such attacks. Okay, I will show you a little bit more details about how this attack works. Also, as AI and machine learning becomes more powerful, attackers can use them to perform automated large-scale disinformation attacks. And you may have heard a lot about this, like deepfakes, fake news. Okay, all these are misuse examples of AI or machine learning. Okay. So now let's discuss a little bit more detail about how attackers can misuse machine learning to perform automated large-scale privacy attacks. Okay, in particular, I will discuss the Facebook data privacy scandal. So let's suppose we have these 5 Facebook users, okay, A, B, C, D, E, and these users have made their page likes public. Okay. However, and also 4 users, B, C, D, E, have made their gender information public. However, user A thinks gender is private and does not disclose it. Okay, so we call this a private attribute. In the Facebook data privacy scandal, the Cambridge Analytica essentially tries to infer user A's gender, okay, male or female. How did the Cambridge Analytica do this? 2 steps. First step, Cambridge Analytica developed a Facebook app, okay, and used that app to collect all this public information from Facebook, okay, including the public page likes and the public gender information. Okay. This is the first step. Second step, Cambridge Analytica learns a classifier, okay, using the public page likes and the gender information of the BCDE users. Okay, so this classifier basically takes a user's page likes as an input and outputs the gender information. In this example, this is basically a binary classifier. Okay. Then Cambridge Analytica applies this classifier to infer A's gender using its public page likes. Okay, so this is how the Cambridge Analytica may have inferred a large amount of Facebook users' private information. And then in this example, I use a gender as a private attribute, but in practice, Cambridge Analytica may have used this technique to infer a lot of private information about Facebook users. Okay, so this is one example about how machine learning could be misused by adversaries. Okay. The second example is deepfakes. Okay. So for example, suppose we have a normal video, okay, someone is talking something, and then if you use AI or ML-based deepfake generation techniques, then you can replace the face of this person as some target person you want, and also you can synthesize the audio. Okay? So basically, you can synthesize some fake video using AI techniques. Okay? So this is another example of misuse of AI. Okay. So to summarize a little bit, how ML could impact security and privacy, basically two things. One is ML could enhance our security capabilities, okay, to better solve conventional cybersecurity problems. However, attackers could also misuse ML, okay, to perform more advanced security and privacy attacks. Okay, and this kind of misuse of ML is a big social and ethical issue, and I think there are a lot of research studies about these problems. Okay? So this is the first part, how machine learning could impact security and privacy as it becomes more and more powerful. Then let's move on to the second part, how security and privacy could impact the deployment of machine learning. So in order to answer this question, let's first look at how machine learning works in practice. Okay. So usually when we use machine learning, we follow the following pipeline. Suppose we have some problem to solve. The first step usually is to collect a training data set. Okay. Then we use some algorithm to learn the hyperparameters. Okay. For example, Professor Lee introduced the last technique to search the neural network architecture. Okay. The neural network architecture is the neural network architecture can be viewed as some hyperparameter of a neural network. Okay. So you use some algorithm to learn the hyperparameters. Then you get the neural network architecture, for example, the hyperparameter. Okay. Then you, given the hyperparameter and the training data, then you have some other algorithm to learn the model parameters. Okay. And finally, you get the model. And after you train the model, you are going to deploy the model, right, for real world use. So you could deploy the model as a client software, like Amazon Echo. Okay. Amazon Echo is kind of a machine learning model, okay, which is deployed as a client software. And you may also see a lot of ML-enabled mobile apps on your smartphone. Okay. So all these are client software. But the model could also be deployed on a cloud service. Okay. We don't have access to the code. We don't have access to the model. We just to search on a cloud service. It's exactly like how we do Google search. Okay. So the model is deployed on the cloud. So no matter it is deployed as a client software or a cloud service, then we have some testing data, then we query the model and then get a prediction result. Okay. So the process of collecting the training data, learning the hyperparameters and learning the model parameter is called the training phase. And the process of deploying the model is called the deployment phase. Okay. So this is basically how machine learning works in practice, okay, roughly speaking. And then after we know how machine learning is used in practice, then we can talk about the security and the privacy problems of this machine learning pipeline. Okay. So let's first look at the security problems. Okay. So when an attacker attacks this machine learning pipeline, the attacker's goal eventually is to attack this machine learning pipeline such that the model makes incorrect predictions. Okay. Or the model makes predictions as the attacker desires. Okay. So if I want the model to predict something for something, then I can compromise the pipeline, okay, to achieve my attack goal. Okay, so that is the attacker's goal. But how to achieve this goal? Right? Just look at this pipeline. One way is that the attacker can somehow change your training data. Okay? If the attacker can carefully inject some bad data into your training data, then the learned model is a bad model. Okay? And the bad model makes predictions as the attacker desires. Okay. Also, the attacker may somehow be able to temper the algorithm that is used to learn the model. Okay. And if the attacker can do this, then the learned model is bad, and the bad model makes predictions as the attacker desires. Okay. So these attacks in which the attacker manipulates the training phase is called poisoning attack. Okay, so this is a big category of attacks called poisoning attacks. The second category of attack is that instead of tempering the training phase, the attacker can also temper the testing phase. Okay, tempering the deployment phase. Okay, so suppose the learned model is good. Okay, the learned model has very high accuracy. However, the attacker can add a little bit of noise, add a little bit of perturbation to its own testing data. Okay, change the testing data a little bit, such that even if the model is a good model, the model still misclassifies the testing data. Okay. So these are called adversarial examples. Okay. So these are two big security issues for machine learning. Okay. So now let's discuss a little bit more details about poisoning attacks and adversarial examples. So poisoning attacks are trying to attack the training phase, okay, of the machine learning pipeline. So in real world, many machine learning systems collect training data from users. For example, recommender systems. Okay, if you watch video on YouTube, if you buy some products on Amazon, okay, you will leave some digital behavior, okay, digital traces on those websites. Okay, those websites will collect all your information. Okay, like for example, you may explicitly read products, okay, write reviews. Okay, so those data are provided by users. Okay, those websites will collect those data from users, okay, and then train their model, and then use their model to provide service to users. Okay, recommender systems, federated learning, crowdsourcing systems. Okay, in all these machine learning systems, training data are usually collected from users. What does this mean? This means malicious users can poison the training data to corrupt the ML model, right? So for example, if I'm an attacker, I can register many fake users, okay, on YouTube, on Amazon. Then all those fake users provide the carefully designed data to YouTube, to Amazon. Okay, when YouTube and Amazon collect data from users to train their model, they will also include the data from my fake users, and then their trained model is bad model, okay, and will benefit me, okay, benefit the attacker. So for example, so these X1, Y1, X2, Y2, X3, Y3 are the original clean training data. Then we can, for example, use some algorithm to learn a model F. And then we have a testing input X, and given the clean model F, we will have the correct output Y. Okay. Now, the malicious users can poison the training data. Now it becomes X1, Y1, X2, Y2, X3, Y3. Now we have X4, Y4. And you train a model on this poisoned training data, okay, then you will get a bad model, F prime. And you have the same testing input X. If you now you have a bad model, F prime, then your predicted label will be Y prime, okay, which will be an incorrect one. Okay. So this is basically a poisoning attack. So let's see a more specific example, poisoning attacks to federated learning. Okay. So federated learning, basically in federated learning, we have many clients. Okay. In this example, these clients are mobile phones. Okay. Each client has its local training data set, and each client maintains a local model, okay, like a local neural network. And we also have a cloud server. This cloud server maintains a global model, which is, for example, which could be simply the average of these local models on the client. Okay. So basically, each client will train a local model and upload the local model to the cloud, and the cloud will average all these local models to get a global model, okay, and then iteratively do these things. Okay. Now, if I'm an attacker, I can inject many fake clients, fake devices into this federated learning system. Okay. For example, here I show just one fake client or malicious client. Okay, and then this fake or malicious client can provide arbitrary training data, okay, local training data, okay, arbitrarily change the local training data. Okay, also the malicious client can arbitrarily change the local model sent to the cloud server. Okay? And then the cloud server will average all these received local models to get the global model. And then the global model is poisoned. Okay? So eventually the global model is a bad model. Okay? So this is one example of poisoning attacks. So now let's move on to the adversary example, okay, which attacks machine learning pipeline at the testing time or deployment time. Okay. Suppose we have this panda image, okay, and we have an image classifier, and the image classifier can correctly predict this image as a panda. Okay. However, we can carefully craft some laws like this. And after we add this carefully crafted laws to the panda image, we get this image. To us, okay, to human, this image is still a panda image. However, the image classifier will predict this image as a monkey, okay, which is incorrect. This image with carefully crafted laws is called an adversarial example. Okay. So this is an adversarial example at testing time. And our research group is interested in building provably robust machine learning techniques against these poisoning attacks and adversary examples. Okay. First of all, poisoning attacks and adversary examples are big security challenges to machine learning when deployed in safety and security critical application domains. For example, cybersecurity. Okay. If we try to leverage machine learning to solve cybersecurity problems, we are dealing with attackers. Attackers will always change their attack strategies, okay, to evade our defense. So we have to, for example, if we apply ML to solve security problems, attackers can use poisoning attacks and adversary examples to attack our machine learning defense. Okay, so we have to make machine learning robust, or we have to make machine learning secure in order to apply machine learning to solve cybersecurity problems. Okay. Also, automated weapons, okay, precision healthcare, and self-driving cars. Okay. All these safety and security critical application domains require us to solve these resolve the poisoning attacks and the adversary examples. Okay. So the big question is how to redesign machine learning to be provably robust against poisoning attacks and adversary examples. Okay. Traditionally, when we design machine learning techniques, we mainly care about accuracy and efficiency. Okay. We want our model to be more accurate, to be more efficient. However, the security and the privacy aspects are largely ignored. Okay. So if we want to consider the security and privacy problems, we have to rethink how to design a machine learning pipeline. Okay. So I'm going to give you one example about how can we design provably robust machine learning techniques against poisoning attacks. Okay. So first, let's define what do we mean by provably robust machine learning. Okay. So we see a learning algorithm. A machine learning algorithm is provably robust against poisoning attacks if its learned model probably predicts the same label for a testing input when the number of modified, deleted, added training examples is bounded. Okay. So what does this mean? This basically means, let's say we have 100 training examples. Now I have a learning algorithm. I have 100 training examples. I use my learning algorithm to learn a model, okay, on the 100 training examples. Then my model is going to predict the label Y for some testing input. Okay. Then I arbitrarily, for example, I insert 10 arbitrary training examples into your training data set. Okay. Now your training data set becomes 110 training examples. Okay. However, 10 of them arbitrarily manipulated by an attacker. Okay. Now I want your learning algorithm, okay, to learn a model on these 110 training examples. And the learned model should still predict the same label for the testing input. Okay, for example, should still predict label Y for the testing input. Okay? No matter how the attacker manipulates those 10 training examples. Okay, and we should have theoretically proved this. Okay? So this is roughly speaking, this is a definition of provably robust learning algorithm. Now I give you one example, okay, how to design such kind of provably robust algorithm. Okay, so we didn't invent any new learning algorithm. We just show that bagging. First of all, bagging is a very classic ensemble learning method. It was invented in 1996. Okay, so how does this method work? For example, this is your training data set. When you train the model, you don't just train one model. You subsample the training data set, okay, many times, okay, and train many models. Okay. For example, in this figure, I show you we train 3 models. Okay, this is your original training data set. I random sample 2 training examples, okay, for 3 times, and then I train 3 models. Okay, F1, F2, F3. As you can see, right, F1, F2 are trained on the original clean training examples, but F3 is trained on a subsample which includes a poisoned training example. Okay, so F3 may be corrupted. F3 is a bad model, but F1, F2 are still good, right? Now, when we do testing, we have a testing input X. Then we are going to use each of these models to predict the label for X. Okay? For example, F1 predicts Y, F2 predicts Y, F3 is a bad model, which predicts Y prime for X. Okay? But then we take a majority vote among these models. Okay? After taking majority vote, we will still get Y. Okay? So this is how bagging works. Okay? And we basically theoretically prove that if you use this bagging algorithm, actually we can already achieve provable robustness against the poisoning attacks. Okay? So this is just one example of provably robust learning algorithms. Okay? So we have discussed how will security impact the deployment of machine learning. Let's move on to how privacy could impact the deployment of machine learning. Okay. So when we talk about the privacy, I will talk about the privacy for both model providers and users. Okay. Again, let's come back to the machine learning pipeline. Okay. This is how machine learning works in practice. Now let's look at this pipeline. If you are a model provider, for example, you are Google, Facebook, okay, all those big companies, which spend a lot of resource collecting the training data set, learning the hyperparameters and the model parameters, okay, and hiring a lot of PhDs, okay, to design sophisticated learning algorithms, okay, to learn good models, okay. So from the model provider's perspective, all these things, training data, algorithms to learn hyperparameters, and algorithms to learn model parameters, okay, and the hyperparameters and the models are all confidential, and they may represent the intellectual property of the model providers. Okay, so one question is, can an attacker steal this information? Right? If I am an attacker, can I steal the training data? Right? I don't want to spend a lot of resource to label a large amount of training data. Can I just steal the training data? Okay, from model provider. Okay, can I steal the algorithms? Okay? Instead of designing the algorithm by myself? Okay, can I steal the model parameters? Okay? Instead of training the model by myself? Okay, so this is the confidentiality, intellectual property for model providers. For users care about the privacy of their sensitive training data, right? If, for example, if the training data is related to the health record, okay? And users may also care about the privacy of their testing data and even prediction results. Okay? So imagine in the future, machine learning and AI really get popular and they are deployed as a cloud service. Okay? And we can use machine learning, we can use AI exactly like how we can use Google search. Okay? So right now, when we use Google search, we just type in a keyword, then we get a search result. Okay? Maybe in the future, those big companies will deploy a lot of machine learning AI models. Okay? If we have some question, if I have some data, I just upload my data, okay, to the cloud, then I get a prediction result. Okay? I don't need to train my model. Okay, I just use the model as a service, as a cloud service. So if that is the case, then the user may care about the privacy of their testing data, right? I may not want to upload my data to Google to use a model, okay? And also the prediction result itself may reveal privacy of the user. For example, if this model is a healthcare related model, okay, which, for example, predicts which type of disease a user may have. Okay. Even if the user does not upload its private data to the cloud, the prediction result itself already reveals a lot of sensitive information about the user. Right? For example, the prediction result may say that the user has heart disease or have some other disease. Okay. So for users, all these information, training, testing, and prediction results may be private. Okay, so to summarize a little bit, for privacy and confidentiality related to the machine learning pipeline, we care about the confidentiality and privacy for both model provider and users. For model providers, we are interested in answering whether an attacker can steal the model parameters, hyperparameters, training data, and learning algorithm from a model provider. Okay? And if an attacker can do so, how can we protect the intellectual property for model providers? Okay. So we can imagine machine learning is a new software. Okay? So traditionally, when we use software like Microsoft Office, okay, those big companies will spend a lot of resource trying to protect the intellectual property of their software. Okay. So if machine learning gets popular and the machine learning is everywhere in our life, okay, then machine learning is essentially a software. Okay? It's a new type of software, and it also requires intellectual property protection. Okay? And how, right? How to protect the intellectual property of machine learning. And for users, right, we are interested in studying whether an attacker can infer sensitive information about users' training data and testing data. Okay? And if an attacker can, how can we defend against these attacks? Okay, so to summarize a little bit, our research group is mainly working on designing new machine learning techniques that are probably secure and privacy preserving. Okay, as I mentioned a few minutes ago, so conventional machine learning research mainly focuses on accuracy and efficiency. Okay? And security privacy aspect is largely ignored. Okay? However, security privacy is a big concern in safety and security critical application domains. Okay? So so our research group tries to design machine learning techniques with provable security and privacy guarantees, and eventually we want to study whether we can make machine learning as cryptography. Okay? So if you have some experience, if you have some knowledge about cryptography, so cryptography usually provides some provable security guarantees. Okay, so cryptography has many building blocks, and when you design some system, when you want to design some secure system, you just combine different building blocks. Okay? Each building block can have some security guarantee, and when you combine different building blocks, you can still do some security analysis. Okay, you can still do security analysis about your entire system. Okay, so can we do something similar for machine learning? Okay, can we build secure machine learning blocks? Okay, and then when we design a machine learning system for specific application, we can combine different building blocks, and still we can do some provable security or privacy analysis about the machine learning system. Okay. So I think this is a very, very big challenge. Okay. If so, we need a lot of talent to solve this problem, and it may take us several decades, okay, to solve this problem if we can. Okay. So to summarize, so our research is basically about the intersection between machine learning and the security. So we mainly study two questions: how will machine learning impact security and privacy, and how will security and privacy impact the deployment of machine learning? Okay, so that concludes my presentation.